the epidemic began. What do I need to determine? Exactly. And we'll plug it in a minute. How many people were ill by the end of the 4th week? What do I have to find? Right, f of 4. So now let's punch in the function in the graphing calculator because we can answer. And then what is the limiting size of the population? Okay, so let's start with that. So let's go to y equals. And in y equals punch in, please. 110 is okay. But the denominator must have parentheses. 1 plus 5,400 times e, in parentheses, negative x. Close the parenthesis for the power and close the parenthesis for the denominator. So now we punch in with second and table. Don't wait for me, get the numbers. Correct. So don't forget the minus has to be this symbol. Okay. So second and table. And we will punch in 0. And then 4. So how many people were ill initially? 20. Very good. And after the 4th week, how many? Perfect. So now they're asking us to find the limiting size of the population, which means that we'll become ill. So for example, we know the answer after 0 weeks. We know the answer after 4 weeks. Now we want to find the answer after 10 weeks, or maybe 30 weeks, or maybe 50 weeks, or maybe 100 weeks. So that's how we determine, that's one way. So let's say 40 weeks. And let's say 50 weeks later, and then 60 weeks later. So what will you say? What is the limiting size of the population that can become ill?
110,000.
Right, and that's the answer. Very good. So part C, as t increases, we say without bound, the function f of t, you don't have to write like this is the correct way, 110,000 people. I just put it in words. As t increases, the limiting size of the population is 110,000. It's a horizontal asymptote. It cannot exceed 110,000. So that was 14. Okay, 15 was done in class. So we have x plus y equals 11. And x minus 3, everything squared, plus y plus 6, everything squared equals 34. I'm sorry? Never. Not at this point. Because I have more work to do. Eventually I will. Yes, Dana, go ahead. Thank you very much. Thank you. So eventually I will expand, but not at this point. So what do we have to do? We have to make a decision. We have to make a decision on how to solve. How do we want to solve? What is the only option here?
Subtract y on both sides.
Very good. So let's say we have negative y minus 11, and we have to replace it in the second equation. So let's replace it. So we have negative y minus 11 and minus 3 will be negative y minus 14, everything squared, plus y plus 6 squared equals 34. And yes, now I agree with Alex. He said expand, we have to. Now we have no choice. So let's expand. I'm sorry? But then you will have to square, you have to square for x, and then you'll have to substitute one more time, because when you expand this, you get x squared minus 6x plus 9. So now you have an x squared to plug in that, and also an x to plug in that. So you're going to have to do double work. But yeah, you will get the same answer. You understand what I'm saying? So you're going to have then x squared minus 6x plus 9. And then you will have to replace this in here and also in here. So that's what I'm saying. You have more work to do. But yeah, eventually you will get to the same answer. Yes? Y squared. Okay. We discussed that from the first day of classes. How many terms we get when we square a binomial? So if you write 2, I will not look at the problem. I'm so sorry. I apologize. I don't want to upset you. But if you write that negative y minus 14 squared is 2 terms, I will not give any points for the problem. I can't. So please make yourself a note. A binomial squared is a trinomial. If I miss this or if I write something wrong and I write only 2 terms, I will not get credit for the problem. Very good. Plus 28y and plus 14 squared is 289. Oh, I'm sorry, 186. No, 96. It cannot be 196. 196, yes. Plus y squared plus 12y plus 36 minus 34 equals 0. So then we have 2y squared, and then I think it's plus 40y, and I think plus 198. Correct me if I'm wrong with my numbers anytime, and of course I will divide by 2. So this is y squared plus 20y plus 99. You must redo the problems we do in class in order to guarantee a good grade on the next test. You must redo all problems we did in class. More than once, possibly. Please. Okay, so if you have difficulties in factoring this, that's fine. Use the quadratic formula and give me 2 solutions, please. Can anyone give us 2 solutions? Do we have 2 solutions for y? Yes, Dana, go ahead. 11 and 9. I agree. So if y is 11, we have to determine x. Oops, when y is 11. And we have to determine x when y is 9. And I'll copy x equals negative y minus 11. You meant negative. Okay. Okay. Yes. So it's y plus 9 and y plus 11. Yes. And then the solutions are these. Correct. Negative 9 and negative 11. Perfect. So when we plug in negative 11, we get x equals 0. Would you agree? When we plug in negative 9, we'll get negative 2. So the solutions are 0, negative 11, and negative 2, negative 9. Would you agree with that? And of course, you will go back and check. So that was 14. That was, I'm sorry, 15. So now 16. Let's go to 16. So y greater than or equal to x squared minus 49. And then x minus y greater than or equal to negative 7. What do you think about this problem? What are you thinking of? What do you think about this? Say it again.
With the x squared where y is, we replace y for x squared minus 49.
Okay, anyone else? We have to graph, we have to shape. It's an area, it's a region in the of the plane. It's nothing to do with solving an inequality. We can't solve an inequality with two solutions like that, with the two variables like that. So please do not confuse things. This is a system of inequalities, right? So this is y equals x squared minus 49. We have to graph this, find the x and y intercepts, and then shade in, etc., etc. As you see, there is a graph, there's a chart here, right? So what do you think? What type of graph is that? What type of function is it? Anyone? Do we know? Have we seen this function before? What is it? Quadratic, of course. How many x-intercepts does it have? We know how to graph this. It's x squared down negative 49, right? It crosses twice. Where? We just did this problem last time. I'm hoping you're going to find the time between now and Monday, please, for me. For me. Very good. I'm going to say that this is negative 49. I'm going to say that this is positive 7, and this is negative 7. So this is the graph. It's a solid curve because of the equal symbol. Now we plug in 0, 0 in the inequality. Is 0 greater than or equal to negative 49? If you say yes, I'll shade in the inside. If you say no, I'll shade in the outside. It is yes, very good. So we'll shade in the inside. This is y greater than or equal to x squared minus 49. The graph of the function is only y equals x squared minus 49. So what do we do next? We repeat for the second one, right? Okay. So for the second one, I have a line, which is x minus y equals negative 7. When x is 0, how much is y? Y is 7, so 0, comma 7. And when y is 0, how much is x? Very good. So negative 7, comma 0. So negative 7, comma 0 is this point, and 0, comma 7 is this point. Since the equal symbol is there, I'm going to graph it as a solid line. I will extend the graph for this. Okay, so now I see that this line divides the plane into two regions, the below and the above. I'm choosing the 0, 0 again. Is 0 greater than or equal to negative 7? If you say yes, I will shade in the region with that. Is it yes? It is yes. Perfect. On the line, I write x minus y equals negative 7, but in the region, I write x minus y greater than or equal to negative 7. And now, if these two do not overlap, then there is no solution of the system. Do they overlap? Yes, they overlap. So there is a solution. And the solution is exactly the intersection where we have, so this is both the green territory including the points on the lines and the curve, the function, the quadratic function. Are part of the solution. Very good. Okay, let's see what 17 is telling us. Yes, the 17 is Gauss-Jordan, and of course, I will definitely allow Gaussian elimination. If you prefer Gaussian elimination, I'm happy. Whatever you decide. Let's start. Let's start. How do we start? What we have to determine first or write first? The augmented matrix. Very good. So let's start with the augmented matrix. And after this, if we don't have anything else to choose from here, this is just for you to practice with again and again and look at the solutions in the notes or your notes. I like to choose some other problems. After we work on this problem. I have plenty. I copied several. So if you think it would be beneficial for you to get another copy, I'll give another copy. They're all the same. Anyone wants another copy? Thank you. Okay, so we are working on the augmented matrix that we have, which is 1, 1, 1, 1, negative 1, negative 1, 1, negative 1, 1, 0, negative 4, 2. So we multiply the first row to add it to row 2 and row 3. Correct. Very good. So we multiply this by what to eliminate this? Good. And we multiply this by what to eliminate this? Excellent. Which row do I have to copy because I'm using it? Excellent. So let's see what we get. Missed you? Okay, so 1 times negative 1. So 1 times negative 1 plus 1. 1 times negative 1 minus 1. 1 times negative 1 minus 1. 0 times negative 1 minus 4. Negative 1 times negative 1 plus 1. Negative 1 times negative 1 minus 1. 1 times negative 1 plus 1. And then 2. What is the next step now? Divide row 2 by? Okay. So 1, 1, 1, 0. 0, 1, 1, 2. 0, negative 2, 0, 2. Which row we have to use next? Since it's the second step, it must be row 2. Okay. What do we multiply by? to eliminate the 1. Perfect. What do we multiply by to eliminate the negative 2? Perfect. So which row do I copy? Perfect. So let's see. 1 times negative 1 plus 1. 1 times negative 1 plus 1. 2 times negative 1 plus 0. 1 times 2 minus 2. 1 times 2 plus 0. 2 times 2 plus 2. We accomplished a lot. But now we need to divide the row 3 by 2. So then we have 1, 0, 0, negative 2, 0, 1, 1, 2, 0, 0, 1, 3. And luckily for us, we only want to eliminate one number. So we only multiply row 3 by something to add it to row 2. There is no need to add it to row 1. I already have the 0. It just happened. So what do we multiply by to eliminate this? Negative 1. So one times negative 1 plus 1. 3 times negative 1 plus 2, negative 1. I hope for this. I want to show you how to check, which is a different method. You don't have to memorize this. You don't have to do anything with this. I just want to show you. Okay, ready? So in matrix, which is right here with a second key, second and matrix, we're going to edit just the coefficient matrix, which is a 3 by 3. And the coefficient matrix is not the augmented matrix. It's just the coefficient of the system, which is 1, 1, 1. 1 again, negative 1, negative 1.
That's a left.
Yeah, it doesn't jump. It's okay. Thank you so much for that. 1. Thank you. Negative 1 and then negative 1. And then the same thing. 1, negative 1, negative 1. So, okay, thank you. So then we go back to second and matrix again. This time we are editing matrix B, which matrix B will be a 3 by 1, which is the augment. And the augment is 0, negative 4, 2. 0, negative 4, and 2. And here is an easy way to determine. This is a totally different system, method of solving systems. So we go to second and matrix. We call matrix A. We must put negative 1 power on it, and we multiply by matrix B. Again, you do not have to memorize any of this. This is not something we did, and I explained in class why we do that. But, you know, to quickly check, I don't know what it doesn't like, but it doesn't like something. Did I copy everything correct? Ah, I didn't. Okay, I see. Okay, I see. Good. Okay. So here's what we get. What does this mean? Alex, what does this mean? Right? -2, -1. So this is another way of checking. You don't have to memorize this, or you go back and just check, as we always did. Okay, I'd like to choose some problems now. Yes, please.
Can you show us how to do the factorial?
Yes. So you go to math, go to probabilities, and then choose 4.
Okay.
Math, probabilities, choose 4. What about expanding and condensing? If not, I would like to look at a log equation. Are we okay with expanding and condensing? Yes? I would like to look at few log equations, or at least one to review. I couldn't hear you.
Condensation.
Yeah, condensing is in the equation. So let's look at an equation, and then if we need more, we'll do more, of course. So let's take a look at 89 on page 515. We have plenty of time to choose. If you want to choose, you can choose any other problem. Equals natural log of x minus 8. Oh, of course we can. So this is a log equation. Remember, if you don't check solutions or state domain, you cannot get full credit. Remember, this is part of the problem, part of the solution. So what is the domain of the first log? X minus 4 greater than 0. What is the domain of the second one? And what is the domain of the next one? X minus 8, we have 3. This one makes 4. This one greater than -1. And this one greater than 8. So which is the common domain then? Very good, indeed. 8 to infinity. So let's condense now. And that's exactly what you were asking, to condense. So let's condense. The left-hand side changes into natural log of what? Yes? Excellent. Thank you. Equals natural log of x minus 8. And what do we do now? Because there is no need to change it into an exponential equation, we're going to say 2 logs are equal and they have the same base. What has to happen here? They should be equal to each other. Very good. So I'm going to expand this into x squared minus 3x minus 4 equals x minus 8. This product, x squared plus x minus 4x and minus 4. So this expression must equal this expression. 2 logs are equal and they have the same base. Very good. So then what do I do next? Exactly, it's quadratic. Awesome. X squared minus 4x and plus 4 equals 0. Well done. Now what? Yes, awesome. How? Great job. Excellent. Well done. 2 solutions, but actually 1. Good. Very good. And we'd like to look at some problems with factorials and the general term and the recursive formula. Ready for that? Yes? Okay, so let's suppose we want to simplify 35 factorial over 29 factorial. How will I simplify this? Which of these two, top or denominator, is bigger? Good. So then I will leave the 29 alone. And what do I write at the top? 35 indeed. Very good. No. Times 29 factorial. So all I have to do is multiply these. I'm hoping that the calculator can do that. I don't know. I have no idea. We'll see in a minute if it can. Okay, 35, 34, 33, 32, 31, and 30. Did I put all of them? 2, 4, 6. 2, 4, 6. Okay, let's see. Okay, it was able to. It's huge, right? 1,168,675,200. 1,168,675,200. Quiet, please. Yes. Any questions on this? Vinny, any questions? Alex, go ahead. Okay. Now let's take a look at a general term and also a recursive formula to determine the first 4 terms. Ready for that? Yes? I have not tried to put this in the graphing calculator. It may not be able to. It may not be able to do it. I don't know. Maybe it simplifies it or not, but be careful with that. Okay, this is chapter 8. I'm looking at the very end with review. Okay, what about a sub n -1 to the nth power n plus 2 over n plus 1. This is not a recursive formula. A sub n does not depend on a sub n minus 1. So I can determine any term you want. So for this one, we were asked to determine the first 4 terms. So we want to find A1, A2, A3, and A4. Okay, so A1, -1 to the first power is negative. 1 plus 2 is 3. 1 plus 1 is 2. A2, -1 to the second power, that's positive. 2 plus 2 is 4. 2 plus 1 is 3. A3, that's negative. 3 plus 2 is 5. 3 plus 1 is 4. Finally, positive. 4 plus 2 is 6. 4 plus 1 is 5. Done. We're asked to find the first 4 terms of the sequence. Now, let's say we're given a recursive formula. A1 is given to be 9, and A sub n is 2 over 3 times a n minus 1. Of course, this formula is for n greater than or equal to 2 because we already have n1, A1, when n is 1. We're asked to determine the same thing. Well, we already have A1, which is 9. we have to determine A2, and then A3, and then A4. So this is a recursive formula because any term depends on the previous one in the sequence. So when A1 is 9, 3 times 9 is 27, so 2 over 27. Now it becomes a little cumbersome because now I have a fraction, but maybe it's simplified. So let's check. So it's 3 times 2 over 27, and I simplify and I get 9. So I have for A3, I have 2 divided by 1 times 9 divided by 2, and it simplifies quite nicely. And I get, for A3, I get 9. Any questions on this? Any questions? And now A4. But A4 will be 2 over 3 times 9, so it's going to be the same number. So A4 is 2 over 27. Well, what if we want to simplify some factorials that we cannot plug in the calculator? Like, for example, let's say n plus 3 factorial divided by n plus 1 factorial. Which one is bigger? N plus 3, so we will leave n plus 1 alone. And please tell me, what will you write on n plus, what will you do with n plus 3 factorial? Yes, n plus 3 indeed, times, indeed, times, yes. And we stop at n plus 1 because we see the denominator is that n plus 1. Excellent. So now when we multiply, we have 2. We get n squared plus 5n plus 6. Any questions? Any questions? Let's take a look at 1/3 plus 2/4 plus 3/5 plus ... plus 15 over 17. They want us to condense this using the sum or the sigma notation or the summation notation. And then please don't let me forget another condensing and expanding. Okay? So let's see which index you would like to use. Okay, I'm using K. You can use any index, any letter you want. So what would you say? Would you agree that the terms, they're all a fraction, so I have to have something at the top and something at the denominator? Would you agree with that? Since they're all fractions, right? Good. So what do you think we're going to have at the top? Indeed. From
1
through 15, indeed. And the top is K. What about the denominator?
K plus 2.
Indeed. This is it. Let's check. When K is 1, I get 1/3. When K is 2, I get 2/4. When K is 3, I get 3/5. ... When K is 15, I get indeed 15 over 17. Should you look at another?
Yes, please.
Perfect. 4 cubed plus 5 cubed plus 6 cubed plus ... plus 13 cubed. Again, they want us a summation. You do not have to start, the sigma doesn't have, or the index doesn't have to start at 1. So it depends on what we have. So let's say we're using J this time. Obviously, there is no fraction, so it must be something to a power. And it has to be power 3 because I see power 3 in all of them. So obviously, that is clear. From j equals what till what? Yeah, exactly. From j equals 4 to, that's it. What do I have here? That's it. When j is 4, I have 4 cubed plus. When j is 5, I have 5 cubed plus 6 cubed plus dot 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 13 cubed. That's it. Okay, let's go back to condensing and expanding more. And these are in chapter 4 under properties 4.3. Can you think of anything else after we look at condensing and expanding? Please speak up. Okay, so let's look at an expanding like 37, page 501. Natural log x cubed, the square root of x squared plus 1 over x plus 1 to the 4th. If you give me this, I will immediately say 2 factors at the top, 1 factor in the denominator, 2 will have plus in front, 1 will have minus in front. I will immediately notice that, so I don't make an error. And then please tell me what to write. So yes, you can 3 ln x. I completely agree. Plus, yes, 1/2 natural log. Very good. You cannot break that. It's a sum. And finally, minus 4 natural log x plus 1. That's it. So now you see it so fast that you don't even need steps. Let's look at condensing now. Another one. 70. Log x plus log x squared minus 4 minus log 15 minus log x plus 2. Again, since we practice, I think, enough of these, you can give the answer right away. How many factors will go to the top? 2. How many factors will go or come, if you want, from the denominator? 2. So this should take a blink. You only have 1 log, remember, not log of, log of, log of, just 1 log. Yes? Correct. However, I can simplify this, so I will have to factor it. So I have log x, x plus 2, x minus 2, over 15, x plus 2, and I'll simplify these. And the simplified form is log x, x minus 2 over 15. Yes?
But yes, doesn't it have to minus in
Say it again.
So you add like negative 15 and minus. Yes, so minus. So maybe 2.
You mean this one?
Yeah.
This one only says that something else follows. Look for it.
Oh, okay.
You don't have to put this one. But if I don't, you may think that this is it. But if I continue with the symbol, then I caution you that something else follows. And you will look at this in the next row. But it's not minus minus. But you're used to writing something else, please do so. You do not have to change to my style. I can't think of anything else other than maybe let's look at some exponential equations, because we haven't looked at exponentials today. Let's say 14 on page 514. Yes, 5 raised to 2 minus x equals 1 over 125. when solving exponential equations, we should always try to present both sides with the same base because it's easier. You can say, no, forget about it, I can apply log. It's fine, but you may not be able to simplify it fully if you don't even try to see if both sides can be presented with the same base. And the answer is, in this case, yes, they can. Because 5 to negative 3 is the same thing with 1 over 125. And this is so much easier now because you have to write 2 minus x equals negative 3. Or negative x equals negative 5 or x equals 5 and you're done. Will you get the same answer with applying log? Of course. Of course. But you may not come up with a solution simplified form. What about graphing exponential and log? That's the only thing that we didn't cover today. We know expanding, condensing. We looked at the logistic growth model. We looked at Gauss-Jordan. We graphed nonlinear inequalities. We looked at the general form of a sequence. We determined the sequence. We determined factorials. We simplified factorials. We looked at condensing and expanding. So the only thing we have left is maybe some graphs or whatever you would like me to go back to. Anything. You can say, I want to see this more, I want to see that more.